So go through some numericals on this flat belt drive. So first we start with this numerical. This is first numerical. So these numericals are taken from different books. So in some books that units are considered in terms of centimeter, or some book they are considered in terms of meter. Major consideration is that you consider a unique unit in all the example as a centimeter. In everywhere there is a centimeter. If you consider meter, everywhere consider in meter. So in this different book they consider, maybe in one book they consider centimeter, another book they consider meter. But unique unit you should use in everywhere in that particular example. So here this is the first example. A prime mover running at the 300 rpm drives the DC generator at 500 rpm by belt drive. Diameter of the pulley on the output shaft of the prime mover is 60 cm. Assuming a slip of 3%, determine the diameter of generator pulley if the belt running over it is 6 mm thick. So here this is a flat belt drive. This example is based on the flat belt drive, where belt drive is given, and that belt drive is used in the generator. That belt drive is used in the generator. So this generator is run by flat belt drive by using this prime mover. Maybe this is genset. This is diesel genset. By diesel engine, it is maybe prime mover, and by that diesel engine it runs DC generator by means of belt. So RPMs are different. Prime mover running at 300 rpm and DC generator run at 500 rpm by means of the belt drive. So N1 is the RPM, prime mover RPM 300 rpm, N2 is the RPM of the generator shaft, that is 500 rpm. So N1 and N2 are given to you. Diameter of the pulley on the output shaft of the prime mover is 60 cm. So D1 is given here. D1 is given for the prime mover is 60 cm, and D2 is asking quantity. D2 diameter is asking quantity. Determine the diameter of the generator pulley. D2 is asking quantity. Now here in this example, slip is given 3%. Slip is given 3%. Total slip is given 3%, and also thickness is also given as a 6 mm thick. If it is not given, then you will not consider this thickness and slip as we observe in this formula. If there are thickness is not given, this T is absent here. If slip is not given, this bracket also absent. But as the thickness is given, slip is given, we should add this into your formula or modified into this formula. Now this is a very simple example. N2 by N1, this is a velocity ratio. N2 by N1 is equal to D1 by D2. As thickness is given, this T is added here. D1 plus T, T1 plus T. And as slip is given, so this bracket is also added here. 100 minus S divided by 100. Now this is a total slip is given. Total slip is given in terms of percentage. So 100 minus S divided by 100. This bracket is introduced as slip is given to you. So you put all the values. N2 is given as 500, N1 300, D1 60, T2 is unknown to you. Plus thickness is 6 mm, so 0.6 centimeter, 0.6 centimeter. 100 minus is 3% is given, S is 3 divided by 100. So after simplification of this D2 now becomes as a 36.85 centimeter. So this is the simple example. So this is based on the velocity ratio. This example is based on velocity ratio, and if thickness and slip are given, that are introduced in this velocity ratio formula. This example is based on simple velocity ratio formula. So another example, induction motor drive the main shaft of the workshop by means of a flat belt. The diameter of the pulley on motor shaft and the main shaft are 45 cm and 75 cm respectively. Another pulley of diameter 50 cm drive a counter shaft having a pulley 70 centimeter keyed to you. If there is a 3% slip on each drive, determine the speed of that counter shaft. If the motor runs at 1400 rpm, neglect thickness of the belt. Thickness of the belt is neglected here, so D1 plus T is absent here. D1 plus T, D2 plus T is absent here. Again, this N1 is the RPM of motor shaft is given, N2 RPM of the main shaft is given, D1 is the diameter of the motor pulley, D2 is the diameter of the first pulley on the main shaft, S is the percentage slip is given. If it is percentage slip is given, you introduce this bracket. If it is not given, this bracket is absent. Now put all the values. Now for N2 and N1, for motor and main shaft. Now if you look at here, from motor to main shaft, and again from RPM of that second pulley on the main shaft driver. So this is a compound belt drive. This is an example based on the compound belt drive. So there are three shafts. One from the motor shaft, again this from motor shaft to the main shaft, another shaft, and again third one is the counter shaft. So there are three shafts, and on the second shaft there are two pulleys. Having speed N2 and N3. So this we can calculate it here. So slips are given for each stages. That's why these are calculated separately. Slips are given for different stages. That's why these are calculated as separately. So N2 by N1 is equal to D1 by D2. Slip is given. So this bracket is added here. So N1 is given 400 rpm. D1, D2 are given 45-75 into this 100 minus 3% slip is given. This RPM, N2 RPM is this much. Now again this RPM is again transferred to the fourth pulley. This RPM is again transferred to the fourth pulley. So from now this RPM is given to the N3. This RPM is given to the N3. So N3 is considered as now as a 814.8 RPM. And that are given to the another pulley. So it is a compound belt drive. From N1 to N4, that speed is transferred. From N1 to N4, power transmitted from first shaft to the another shaft. So here, this N2 and N3 are same. Because on the second shaft, these two pulleys are present, having speed N2 and having speed N3. These are same. As N2 and N3 are based on the same shaft, so this speed of that N2 is equal to speed of that N3, 814.8 into D3 by D4. So for second case N4 by N3 is equal to D3 by D4, and slip is given, so this bracket is present here. So N3 is now becomes as a 814.8 RPM into 50 by 70 into 100 minus 3 by 100. So after simplification we will get 564 RPM. After simplification you get 564 RPM. So third shaft on that third shaft, there are fourth pulley. Their speed is now becomes as a 564 RPM. This is the example based on the compound belt drive. This is a simple example by considering thickness and considering slip. So third example, Third example here. So here third example is given a pulley 15 centimeter in diameter mounted on induction motor. Mounted on that induction motor shaft running at over 950 rpm, drives a workshop main shaft at 300 rpm by welder. The belt is 5 mm thick and 15 cm wide. Determine the size of the pulley on main shaft if there is a slip of 4% between the belt and each pulley. So the effective diameter of this driver pulley. Now thickness is given here. Thickness is given here as a 5 mm thickness. So diameter is a changes by considering thickness d plus t. 15 plus 0.5, so 15.5 centimeter diameter is changes by considering thickness. So as here, so this linear speed of the belt running on the pulley with belt slip, that we can consider as V is equal to pi d1n by 60. So linear speed we can consider as a pi dn by 60. So for first pulley it becomes as a V is equal to pi d1n1 by 60. If thickness is given, that diameter changes to d1 plus t, and if slip is given, one more another bracket is added as 100 minus s1 by 100. So this linear speed of that belt running on that pulley is now becomes as a, so put that values, pi plus d1 plus t now 15.5 into n1 950 by 60, and this bracket 100 minus 3, 100 minus 4, 100 minus slip is given as a 4%, 100 minus 4, 96 divided by 100, so 740 centimeter per second. This is the linear speed on the first pulley, on the driver pulley. So linear speed of the belt on driven pulley also same, but due to slip over the driven pulley, the linear speed of the driven pulley now becomes as a 740 into. Now this speed again reduced due to slip present in between driven pulley and that slip. So this speed is reduced by 740 into this bracket, 100 minus s to by 100. So 740 into 100 minus s to by 100. This speed is equal to now pi d2 plus t. This speed is now equal to the pi dn by 60. So pi d, now d here is d2, n is here n2, and 60. Now as thickness is given, d2 changes by d2 plus t. So pi dn by 60. D now refer for d2, n refer for t, n2, and as thickness is given, it refers as a d2 plus t. So pi d2 plus t into 300 divided by 60. So after simplification of this, s2 value is again 4, consider as a 4, s2 value. Thickness is given as a 5. So there is only unknown is a d2, So after simplification of this, you will get 44.7 centimeter diameter of this particular driven pulley. D2 is equal to 44.7 centimeter. So these examples are based on simple formula. Here we consider that linear speed of that particular belt, running over the, and that linear speed of that belt is same over the driven pulley and the driver pulley. That linear speed of that particular belt is same over the driven pulley and the driver pulley. That's why we equate this. This value. This is linear speed of this first speed of the belt on the first pulley, and linear speed of that belt on the second pulley. We equate this as both are equal. We equate this, and then we can find out the diameter of the second pulley as 44.7 centimeter. Now, fourth example. There are two parallel shafts connected by a cross belt drive, having a diameter of the pulley 40 cm and 60 cm respectively. The direction of rotation of the driven shaft is required to be reversed. Now, as it is a cross belt drive, direction of the driven shaft must be reversed by changing over to an open belt drive. Changing over an open belt drive, state if the same belt can be used. State if the same belt can be used. If not, what is the remedy? Assume that the center distance between the shaft is fixed at 6 meters. So in this example, one cross belt drive is given, and the direction they want to reverse, the direction of the driven shaft they want to the reverse by changing it to the open belt drive, and they ask whether it is possible. So we find out this length of that particular belt. So we use here length of that particular belt formula. Now that cross belt drive is now shifted by open belt drive. So whatever that length of that cross belt drive must be equal to that length of that open belt drive. Then and then only we can use that particular belt or we can change that cross belt drive to the open belt drive without changing that particular belt. If that length of that belt is same, for both the cases, open belt drive and cross belt drive. If it is different one, we suggest that belt size should be reduced by some amount. Or increased by some amount, so that we can use to the another belt drive. So here cross belt drive is changes to the open belt drive. So whatever that length of belt used in that cross belt drive, that should be equal to the length of that belt that we use for that open belt drive. And in both cases that center distance are fixed as a 6 meter. Center distance between that two shafts is fixed as a 6 meter. It is given to you. So if that length of the belt is not same, then we suggest that we can reduce that length of the belt by some amount by calculating. Now for conclusion of that whether this belt is same or not, we first calculate the length of that cross belt and length of that open belt. So we first calculate length of the cross belt, length of the open belt. Now here these are given. For cross belt we have this formula sin alpha is equal to R1 plus R2 by D. This D is nothing but the distance between the two shafts. Which is given as 6 meters. So R1 is the radius of the driver pulley, R2 is the radius of the driven pulley, and D is the center distance. Center distance or distance between the two shafts. Now, so sin alpha you can calculate R1, put that R1 value is given as a, so diameters are given. Diameter of the pulley is given 40 cm, 60 cm. So R1 and R2 are the 20 and 30 divided by 6 into this 100. So these are considered in centimeter. So this 6 also considered in centimeter. So this sin alpha becomes now 0.0834. So alpha is becomes as a 4 degree 47 minutes. So in terms of radian, it becomes as a 0.0834 radian. So 0.0834 radian. So this is now alpha value. This is alpha value. So sin alpha, this alpha is very, very small. So sin alpha and alpha value, if you observe here, these are same. And cos alpha is now this much. So length of that cross belt given. And then we have formula 2 into D cos alpha plus R1 plus R2 into 5 2 plus alpha. So we put all these value. 2 D value is 6 into 100. Cos alpha value R1 plus R2 is 30 plus 20 is 50. And 5 by 2 plus alpha value is given as a 0.0834. So this L is given now like this. This L is now given as like this. So this L for cross belt we can calculate it like this. L for open belt having formula 2d plus by r1 plus r2 plus r2 minus r1 bracket square by d. So put all the values 2 into 6 into 100, 5 into 20 plus 30, 50 plus r2 minus r1, 50 minus 20, 30 minus 20, it becomes as a 10 square divided by 6 into 100. So after simplification, this will becomes as a 1357.166 centimeter. If you look at these two length, these are different. These are different by some amount, and that difference is nothing but a 4.038 centimeter. Therefore, this difference is this much. This difference is this much. So here this conclusion, this it is always it is written as a always that so long as the centers are fixed, center is not changing for the same set of the poles, length will not suit the cross belt as well as the open belt drive. So easy remedy. How you can now you can fit that particular belt. So this belt for cross belt drive is some 4 centimeter long. So we reduce this belt by 4 centimeter, this much of amount, and then we can use for the open belt drive. So this is the example based on the length of the belt. This is the example based on the length of the belt formula. This is the example based on the length of the belt formula. Now, so this is the example. This is the example based on the length of that cross belt drive and open belt drive. Again,